Hello, math students. Welcome back to our module called Expressions and Equations. This is lesson 14, and it is called Writing and Evaluating Expressions with Exponents. Our goal for today we will practice writing expressions that involve the use of exponents. The question that I want you to be thinking about during this lesson is, what is the pattern that you see when increasing and decreasing the exponent's value? So there are some things to remember that we need to pay attention to just because you've been working on this with your latest assessment that you took, and also because expanded form is very important to remember. So it says write each power in expanded form. So when we see 2 to the 5th power, the way we remember to do that is 2 is the base, the exponent is 5, so 2 to the power of 5 means that I have to take 2 times itself 5 times because the exponent says 5. Then the next one says that I need to do 2 to the 4th power. So again, 2 is the base, 4 is the exponent, so I have to do the 2 4 times, okay? And then the next one says that I need to do 2 to the 3rd power, so that means that I would take the base is 2, and I would multiply it by itself 3 times, because that is what the exponent says. So there's 2 to the 3rd power. Another name for 2 to the 3rd power means that it is cubed. So it would be the base is 2, and the exponent is 3, and so we would do it 3 times, right? And then I have 2 to the 2nd power. So that means that the base is 2, and I have to multiply it by itself 2 times, and we also know that is 2 squared, and then it says 2 to the 1st power, so that means that I just have 2, and then, this is where you need to start looking at the pattern. So we have 2 to the 5th power means 5 times, 2 to the 4th power means 4 times, 2 to the 3rd power means 3 times, 2 to the 2nd power means 2 times, 2 to the power of 1 means 1, 2, but then how do we do 2 to the 0 power? Well, if we look at it, each time we are going down in exponents, we're actually reducing it by 2, right? So here's 2 to the 5th, so there's 5 2's. Then we went down 1, and we have less 2's. So instead of being multiplied by 5, we now multiply it by 4. Then we multiplied it 3. Then we multiplied it 2. Then we didn't multiply it at all. There was just 1, 2. So what happens if we have 2 to the 0th power? 2 to the 0th power means that you get an answer of 1. Okay, so let's look at it like this. What if we had 2 times 2 times 2 times 2 times 2, and then we divide by 2? That would give us 2 to the 4th power. 2 times 2 times 2 times 2 divided by 2 gives us 2 to the 3rd power. 2 times 2 times 2 divided by 2 gives us 2 to the 2nd power. 2 times 2 divided by 2 gives us only 2 to the 1st power. And then if we divide this one by 2, we get 1. Okay, and so there's a very, very powerful thing that has just occurred, and I hope you were paying attention to it. Any base raised to the power of 0 will always equal 1. I need you to remember that. Let me say it again. Any base raised to the 0 power always equals 1, because you noticed it when the exponent was decreasing by 1. So 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1, 1 minus 1 is 0. So when the exponents are decreasing by 1, that means they're being subtracted. What we're actually doing is we're dividing off a 2 from the previous time. So 5 2's, divide by 2, you get 4 2's, divide by 2, you get 3 2's, divide by 2, you get 2 2's, divide by 2, you get 1 2, divide by 2, you get 1. okay? And so that's how we need to build and recognize the pattern when it comes to working with exponents, okay? So it's kind of cool. Do you see the pattern? And the answer is yes, we do. Yes, we do. And the pattern is when the exponent decreases, did I spell exponent right? Yes. When the exponent decreases by 1, the expanded form is divided by the base. And you need to remember that, okay? So that's the pattern when you have exponents that are decreasing in value by 1, okay? So do you see the pattern? Yes, we do. When the exponent decreases by 1, the expanded form is divided by the base. And that's exactly what happened. 2 to the 5th, 5 2s. 5 minus 1 is 4. Divide this by 2 and you get 2 to the 4th. Divide this by 2 and you get 2 to the 3rd. Divide this by 2 and you get 2 to the 2nd. Divide this by 2, you get 2 to just itself, 2 to the 1st, and then divide that by 2 and you get 2 to the 0. Okay? So it's kind of cool. What happened each time you wrote the power in expanded form? Each time we wrote the power in expanded form, the number of bases decreased. So what happened each time you wrote the power in expanded form? The number of bases decreased while the exponent decreased. Okay, so that's kind of interesting. All right, so let's look at the try this now. You have a table. What you are supposed to do on this table is you're supposed to fill it in what you see. So we have a power of 5, 2 to the 5, okay? So in expanded form, that means 2 times 2 times 2 times 2 times 2. We divide by the base, so we take 2 times 2 times 2 times 2 times 2 and divide that by 2. Then we're left with 2 to the 4th power, okay? So then what we are going to do is we are going to start with 2 to the 4th, which means 2 times 2 times 2 times 2. That's expanded form. Then we take that expanded form, 2 times 2 times 2 times 2, and we divide it by the base, right? And we're left with 2 to the 3rd power. Okay? So now we're taking 2 to the 3rd power, and 2 to the 3rd power means 2 times 2 times 2, and we're dividing that by 2, and we end up with 2 to the 2nd power. Okay? And then we take that 2 to the 2nd power, and again, we divide it by the base, so 2 times 2 divided by 2, and that leaves us with 2 to the 1st power, and then we take 2 to the 1st power, and it looks like this, right? Divide it by the base, 2 divided by 2 gives us 2 to the 0 power. Okay? Oh, you missed that because you didn't see it. So 2 to the 1st power means 1, 2, divided by the base, and we end up with 2 to the 0th power because we're watching the pattern of the exponents decreasing by 1. So 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1, and then we end up with 2 to the 0th power, right, which is 1. And if we take 1 and divide it by 2, then we get 2 to the negative 1 power. Okay? So you're just doing everything by pattern. So 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1, 1 minus 1 is 0. 2 to the fourth, 2 to the third, 2 to the second, 2 to the first, 2 to the 0, and 2 to the -1, because you're counting on a number line, and the number that is to the left of 0 on the number line is -1. Okay? And so that proves to you what the values of all of them would be. So if we drew one more category in there, just to do one more to see what's going to happen with that last piece, and I guess I should choose a marker that works so that you can actually see it. That would be a lot more helpful. So we're going to add one more column to our table and see what happens to the pattern. So we started out here at 2 to the -1. Well, we now know that 2 to the -1 actually means 1/2, right? Then we're supposed to take 1/2 and divide it by the base, which is 2 over 1, right? That's what we're supposed to do. And so since this is dividing, we have to find a common denominator. So the common denominator would be 2. So we have 1/2 divided by, if that becomes a 2, then this has to become a 4, right? Over 2. And then we have 2 divided by 2 is 1, and 1 divided by 4 is 1/4, right? And 1/4 is really 1 divided by 2 to the second power. So that's what it's looking like when we get it done. Or the other way we write it is 2 to the -2. Okay? Now, this is an 8th grade standard, so please, 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 please don't worry about it. Okay? This is an 8th grade standard. However, these up here that are all part of the table, that's a 6th grade standard. You should be able to see that 2 to the 5th is this. When you divide it by the base, you get 2 to the 4th. 2 to the 4th is this. Divided by the base of 2, you get 2 to the 3rd. 2 to the 3rd is this. Divided by the base, you get 2 to the 2nd. 2 to the 2nd is this. Divided by the base is 2 to the 1st. 2 to the 1st is this. Divided by 2, you get 1, which we already recognized as 2 to the 0. 2 to the 0 means 1. Divide it by the base, and you get 2 to the -1. Okay? So it's all about patterning when you're working with exponents, and it's all about remembering specific rules. The thing that I want more than anything for you to remember on this whole lesson is to remember that whenever you have a base that's raised to the 0 power, your answer will always be 1. Always. Okay? It could be 5 to the 29th power, and then I say 5 to the 0th power, you need to say 1. If I say 1,000,000 to the 5th power, then I want you to figure that out, and then I would say 1,000,000 to 0, you better say 1. Okay? So that's what I want you to remember. Any base raised to the 0th power, you're always going to get an answer of 1. Okay, so let's go back up to our goal for today. Today we will practice writing expressions that involve the use of exponents, which we just did in this table. What is the pattern that you see when increasing and decreasing the exponent's value? When you increase it, the value of the exponent increases by 1. When you decrease it, the value of the exponent goes down by 1. Okay, and which means that you're dividing by the base. When it's increasing, it means you multiply by the base. Okay? All right, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye!